So the next part here for the wheel assembly is the axle support. We don't need to make two of these. Again, we have an endless parts bin. We can bring in as many parts as we need to. We do have a rib here, 12 millimeters with this 2 millimeter overhang, and we do have tangent line construction. We have counterbore holes, and this needs to be exact so it can line up to their piece. Again in millimeters, and we have fillets that are radius of 10. Sorry, radius of 2. Okay, let's make this one. Being that I'm already in millimeters, I am then going to start my sketch. Inside and outside diameter. I'm going to create a construction line just so I can use my center rectangle tool to align these, to eliminate some measurements that I would need. So from this top edge to the center of the circle is 58. The overall width is 82. And the overall thickness of this base material is 10. Outside radius is given. I drew a circle, so 20 times 2 is 40, and an inside diameter of 18. Tangent line construction. I am looking for that tangency symbol, or I can add the constraint that this line and this arc are tangent. Either way, I got the same end result, and I am looking to extrude this, and I'm only going to extrude this 10 millimeters to start. So I don't forget, I'm going to add the 2 millimeter offset here. Construction should go pretty quickly. 18, 40, and add the 2. So that this distance from here to here is now 12 millimeters. The rest of this base can be done with the rectangle tool. Keeping in mind that I have already created 10 millimeters of thickness and I need 37 total. Based on the way that I've constructed this, I'm going to now add 27 millimeters so that this distance from here to the surface is now 37. Again, using our fillet tool at a radius of 12 will help us align for these holes. So using our hole tool, we are creating a counterbore on this face. The drill depth is going all the way through. It's over 10 millimeters. The diameter of the counterbore is 22. The depth is 2. Drill point angle is not going to matter. We're going all the way through. And a drill diameter of 11. I'm going to create a concentric relationship. And now when I go to add the other hole, all my dimensions are already set. I'm going to reference this edge. We're set up. And now I want to create a rib. So again, if I add this plane down the middle, process we looked at before, by setting a plane that goes down the middle, I can now sketch on this plane. And I'm going to use the rib tool this time. I want to create a line. And I'm just going to set it here, and now I'm going to add the relationship, or the constraint. That is coincident, and this is coincident, and now add my dimensions. So from here to here is 20, and the distance from the base is 32. I'm going to turn this line into a rib. So when I go to solids, I'm going to create a rib. I'm going to reference this line. Most of the times ours are symmetrical. I want to go up to next, and my rib thickness is 18 millimeters. This will put it 9 millimeters on both sides. You can see that being generated here. If it happens to be going the wrong direction, you can flip it, which mine happen to be okay. And all I need to do is add some fillets. We have casting fillets that are a radius of 2. I'll put a few on and add the remainders. There's some of them. This edge should run all the way around. And we have some fillets along this back edge. Oh, I forgot one. I still forgot one. Okay. Material, malleable cast iron. And machine surfaces. Mating surfaces, because this attaches to the other machine surface. Holes are always machined. This surface is a mating surface, machined, and the holes themselves. And the counterbore. All right. So there is the axle support. We only need to create one.